the Clean Water Act was just 1 month old when I went back for my PhD. And basically the Clean Water Act said, you can't poison the fish. But there wasn't anything in the Clean Water Act that said you couldn't take all their water. So that's basically the sort of problem we had in the West, is sort of taking all the water. And you say, now, wait a minute, in the future, we're not going to do that. We have to provide water for ecosystems. Social attitudes have changed. It's the right thing to do. But what does that mean? It means it's just it's another big challenge. In California, it's the biggest challenge that we face in the state of how do we meet the freshwater needs for ecosystems while still providing that for agriculture and for urban areas. My father always gave me presents like microscopes or little woodworking kits. Or when I was in 6th grade, I got the world's biggest chemistry set, the kind they don't sell nowadays. And I do all those experiments. And I'd say in a sort of a general way, he sort of influenced me a certain direction, or maybe he saw there that I had an interest and he just nurtured it without being overbearing. Worked one summer at a chemical plant and thought maybe that wasn't the right career for me. I didn't know quite what to do when I graduated in chemical engineering. But at that time, this was 1967, there was a lot of interest in marine resources and sort of going into the ocean, just like there was a space program to go to the moon. So I went out to Hawaii and studied ocean engineering. And at that time, I finished a master's degree there. And that was in 1969 now. It took a year and a half. The Vietnam War was on, and I had a choice. I could get drafted or volunteer. And so I volunteered, and I volunteered for the Navy Civil Engineer Corps, went to officer school, and then later became a deep-sea diving officer in the Navy Civil Engineer Corps and worked with a group of divers. Later after that, when I got out of the Navy, I went back to Berkeley on GI Bill and got a master's and PhD in environmental engineering. So there's a little bit of a story there that I wasn't quite sure what direction my career would take. At the time when I was in the Navy with this group of divers, some of my friends from undergraduate days were in law school and business school, and I had a rambunctious group of divers and some diving boats, and thought my career was going a little bit on a different track than my friends from college. Well, it turned out that time in the Navy was a time for me to think about what I want to do with the rest of my life. When I was in diving school, the diving school was actually in Washington, D.C. at the Navy Yard. And we would dive in the Anacostia River. On the weekends, we had time off and spend time on the Capitol Mall. And there was, I got interested in the Smithsonian newsletter, and read, problems with DDT and the brown pelicans dying off and the like. I'd not been exposed to that before. Read books like Silent Spring by Rachel Carson in 1970 also. There was Earth Day and the founding of the EPA. So all of that, while I was in the Navy, sort of made me think about the future in environmental engineering. So there was a separation point coming, and at that time I thought, well, I could go back to California. I had in-state tuition. With the GI Bill, my wife and I would have a little financial cushion. We had a son at the time, so we weren't going to be completely broke. And then went back to Berkeley for the graduate degree. So one part, I guess, of my life story here is that if it weren't for the Navy, I wouldn't be a professor. My wife and I got very interested in environmental affairs on the base, and were involved with recycling very early on, along with others, and sort of embraced the goals of the environmental movement. We weren't activists, but we're just trying to do the right thing. So that sort of attention meant that on the environment meant that when I was finishing my degree, there were job opportunities in academia, and the skills that are needed to work on environmental problems are different than sort of mainline structural engineering sort of skills. So myself, Paul Roberts, and Jerry Schnorr, to name some other examples, were among the sort of first wave of environmental engineers to come into academia in civil engineering departments where our background, our undergraduate degree, was not in civil engineering. It was chemical engineering, which ended up being a very good field for study of environmental problems. And when I went back, I was older than about every other student in the program. And I was worried about whether I'd be able to pass the classes, because, I'd been out of the classroom for a while. It turned out I did fine, and but when I went back, my concerns were, would I pass the classes? And I had no idea I'd be a professor. And it wasn't until I got near the end of the PhD that, being a little older, I looked around my professors and I thought, well, they had a pretty interesting life. They seemed to work hard, but they were very independent. And I guess I valued the independence and thought, well, I'll try being a professor and see how that goes. And well, it's gone fine. And then there were the challenges of starting up as a professor, going to Carnegie Mellon, where there were no labs, no facilities. I was the environmental engineer at the time, though there was a program in engineering and public policy. So there was work being done on environmental policy, but not environmental engineering as we think of it, that has components of lab work, field work, and some modeling. So it was a little challenge to get started there, but things fell into place, and it was a very good institution, had lots of support there, and a little bit of luck on things. As professors, we're all challenged with how to teach our classes when we begin. It's always a new experience, and it's a learning experience every year. It's something we always work on. It's a challenge to start and sustain a research program. But with challenges, there are opportunities. Maintaining the research program is a little bit like being in a long race. I don't know if it's quite like a marathon. Maybe it is. That, if you're kind of in the lead pack, you just keep going, and that kind of stimulates you to keep going. If you were to sort of get off the track and take a detour for a while, then it's like you kind of lose feeling for where the field's going. You lose momentum. And I think, I don't know how you'd get back into it. So you keep going, but the problems you work on evolve with time. And early on in my career, I was interested in synthetic fuels and worked on the water-related problems of coal gasification and coal liquefaction. And that was a long time ago, but I worked on certain problems there involving certain kinds of aromatic compounds, polycyclic aromatic compounds, behavior of cyanide, phase separations and partitioning compounds, issues of tars and emulsions. And that kind of sort of problems have stuck with me a long time. The idea of mass transfer, phase association, reactions, and kinetics. My work over time then advanced beyond that into sediments, and then dealing with the availability of contaminants in general, and how that can assess, how we can use that to do a better job of risk assessment and think about cleanup strategies by controlling the availability of contaminants. And then more recently looking at just sort of the broader issues of our water infrastructure. So I guess you could say that they're these sort of outside events, like the focus on synthetic fuels early on. The government was supporting that. The interest then into hazardous waste and compounds and groundwater and soil cleanup. And I worked on that for a while. But I sort of thought that the area of sediments was an important area that was understudied and underfunded by the government, and moved into that area and sort of got in there a little bit ahead of some other things, other people, I should say, and have had a good program in that. And then more recently, working on how we deal with our water issues in the western United States, in the sort of semi-arid region of the country. In the area of the western water challenges, we have the aging infrastructure, we have the population increase, We have issues of climate change to deal with. And these forces then all put stresses on the way that we bring water into the urban centers and how we use and reuse our water in the urban environment. So there's an opportunity with these challenges, with the infrastructure that's wearing out and the new pressures we face, to do something new and different. Also, in the West, historically what we've done is taken water from remote areas and brought it into the cities. This is true for San Francisco, Bay Area, Los Angeles, San Diego, the Denver Front Range, and the like. Well, that was done at the expense of taking water from ecosystems. So there's another big challenge facing us, is how do we provide safe and wholesome and reliable water supply while still meeting the water needs of ecosystems.